The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.
All right, check out this sweet riff.
Whoa, Felix, stop. This isn't gonna work. You have an acoustic electric guitar, and I just have an acoustic guitar. Clearly this isn't gonna work.
Hey, I got an idea. We can take an acoustic guitar, add a preamp, and a microcontroller so that it can record itself.
Yeah, I guess it's pretty sweet.
All right, let's do it.
Felix, I don't know why you keep playing. I said this isn't gonna work. You can stop now. Felix. Okay.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, look, I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Hello, and welcome back to the Ben Heck Show. Ben is on vacation right now, so this week Felix is going to be doing our build. Felix, tell us about your guitar.
All right, well, I have a little diagram here of the surgery that I'm gonna do. So this represents the acoustic guitar. These red lines represent where I will be putting some holes in the guitar. At the top for the main preamp circuitry, and then at the bottom for the preamp jacks. I'll also need to drill a hole in the bridge to put the piezo pickup underneath the saddle. Then I'll plug those into the main preamp box, and then I will also need to add in a microcontroller. I was thinking about putting it inside, but I'll probably put it outside because I want to be able to access the SD card and maybe reprogram the microcontroller if I need to.
That sounds really cool.
Let's go make something. All right, so here is the project guitar. This is going to be the one that I turn into the guitar that records itself. And this is the control group, I'm calling it. It's a standard acoustic electric guitar which does not record itself. And the reason I got it is because I want to see what kind of recordings I can get in this audio codec that I'm using, which is the VLSI-103B. What this little package here has is the audio codec plus all the circuitry necessary to record onto a micro SD card, which is pretty nice and handy. What's real important is the preamp. I have two different preamps here. They pretty much do the same thing and they work the same way mostly, except this one has an equalizer with 4 levels, and this one has a 3-band equalizer, and this one has a tuner in it. So I think I'm gonna go with the one with the tuner. So what I'll do here is I'll find out where this is centered on this curve here and cut a hole in it, set it down in there. And there's another component that comes with it. There's actually 2 more components that come with it. This one is a piezo pickup, and where it goes is on the bridge here. I'll have to take out the saddle. I'll take off the strings, of course, and take out the saddle, and then it'll fit down here into the bridge, but what I gotta do is drill a hole in there. And then also with the saddle, I'm gonna have to reduce the saddle by the thickness of this piezo pickup here. So then that plugs into the preamp, like so. And then another component is where the jack connects. This is gonna go into a hole in the back of the guitar here. That provides an XLR and a quarter jack. And also that's where the battery is at. What I need to do here, since my idea is to put on a little LCD screen, there's a little TFT screen that I can set maybe here or possibly down here in this area, and then add a few buttons. What I'll do is I'll make a 3D case or enclosure that would actually screw on to or attach to the face, the housing of this preamp in some way. Okay, so what I'm gonna do now is go over to the bench and breadboard a circuit with the microcontroller and the audio codec and TFT screen and some buttons and see what kind of recording I can do, because I'm gonna connect this to it, see how it sounds. Let's go do it. All right, here on the breadboard, I got a few things kitted out. I got a linear voltage regulator, stepping everything down to 5 volts, and a Atmel ATmega 328P and that's the same thing that's on an Arduino Uno. To that, through the SPI, I have a 1.5-inch TFT screen connected, and additionally on the SPI, I have this dev board here, which has the VLSI1053B audio codec and a buffer chip that's connected to a micro SD card slot with the micro SD in it, and that's on the SPI as well. Over here, we have some input pins that are connected to the GPIO on the Atmel, and then a 1/4-inch jack that's going to be connected to the audio codec for input from the guitar just for testing purposes. Then I have this 3.7 watt stereo amplifier. So what I'm gonna do now is write some code to put on the microcontroller to get some feedback when we push buttons on the TFT screen. After that, I'll move on to seeing what kind of audio we can capture with the codec onto the SD card. So the code that I'm going to put on the microcontroller, it's right here. We need to include the Adafruit graphics library and the Adafruit SSD1351 library. And I have some color definitions and text boxes. Let me explain what these text boxes mean. There's top, bottom, left, and then I have clear and print. Basically, the TFT screen is 128 by 128, and since that's the case, I figured that we could have a top, a bottom, two sides, and a center. And in the center, there would be a play icon or a pause icon, or just a media icon. And there in the top, I could have some text output saying what was going on in the bottom as well. And I did some calculations to figure out where everything would need to be in order to draw out the different icons that it will display. I've assigned the SPI pins. I've also assigned some media symbols. Right now, there are 6 buttons connected, and I have them assigned in an array, and then a LED pin on A0 to get the heartbeat. So there's 6 pins, and I have states, high and low, and last button state. That's for handling some debounce routine. So these functions that I have here, I have text box, heartbeat, and media button. Text box is what will draw the top and the bottom of the screen and give whatever text output that I want to have. And then heartbeat is just whenever a GPIO button is pressed, it'll turn the LED on or off. And then the media button will control the display, what's in the center of the display, where I have like play, pause, stop, or record, whatever's there. So the setup, I need to turn the pins into input. I do that with this, I iterate through this array, sending them all as inputs. And then I start the TFT screen. I clear it out and make it black. Now here in the main loop. All right, so we're reading 0, and then we iterate through all the pins and see if they are pressed or not. And we have this debounce routine, very simple debounce routine. There's a switch case for each one of the different pins. So if, say for example, the button that's assigned as play is high, it'll send 1 to heartbeat, it'll send, in this case, play, it'll clear the text box on the top, it'll print play, and then it will go to the media button function and draw a play icon. So it does that for all the different buttons that are connected and assigned. These other 3 just turn on the heartbeat. I'll do a next, a previous, and up and down. I'll add that as well. But right now, I'm just so excited about this. I want to test it out. So let's go check it out. It's time for Felix's Corner. Oh, hi. Bet you wonder what I'm doing under here. While Ben's out on his vacation in space or wherever he's at, I am taking the opportunity to sturdy up his desk, putting these 2x2s and 2x4s under here, making nice braces, replacing these old plywood legs that he had on here. They worked great when it was up against the wall, but now that his bench is out in the open, they're not quite as sturdy. So I replaced all those, and it's real solid now, and he can put on as many 3D printers as he wants, and it's also impervious to attack. there's the stars we're looking for, and this is supposed to be play. Okay, that's cool. Play, record, stop, and the rest of these two buttons, or these 3 buttons, are just gonna flash the LED, to the heartbeat, and these 2 buttons aren't hooked up to anything yet. Now that the play, stop, and record are doing what I would like for them to do, I'm gonna go ahead and add some more code to this and get ready to do a test capturing audio from a guitar through the audio codec onto the SD card. So the demonstration that I've got set up here is the VS1053B breakout board connected to the guitar, and there's 2 programs that I've got. One will record the guitar and the other will play back. Right now they're completely separate because I want to iron them out and get them streamlined before I merge them together. And then also I will then incorporate the graphic display so that it'll all be one program. So I have some code flashed onto the Atmel, and this is the serial output of it. And I have a button here that's set up for record. You can see I've done a few tests here already, and I'm gonna do another one just so you can see what it does. Right now, it's picking up some interference, some radio interference, so you might hear a sports game or something. So the recording has started. Let's see. Oh, look at that. I got, maybe I need to turn on. Maybe I can lower the amp there. Okay. So let's see what that will sound like. So next I will upload the play application, or flash the play program, and it should just start playing what I recorded, as long as it's working correctly. Yeah, there it goes. It's a little distorted. You got some radio signals going on there. Let's see. So that works. I just have to figure out how to remove the radio signal and merge the play with the record into one program. So now that I know what the wiring is going to be for the Atmel and the controller and the display, I think what I'm going to do is go over to the guitar and start doing some surgery and figuring out where I'm going to want to put things, so then I can decide how I will lay it out on the perf board. This is how I prepared the guitar for surgery. I lined up the curve of the preamp with the curve of the body, then I measured and found the center of both the preamp and the guitar body. That enabled me to mark a rectangle for cutting the opening. Next, I decided to embed the pickup into the bridge. First, I had to mark where the saddle was without the pickup. This gave me a great guide so I could file down the difference between where the saddle was with the pickup and where it was without the pickup. First, I used coarse sandpaper and finished off with some finer grit sandpaper. Continuing with the preamp installation, I marked the curve of the battery housing and output jack box with the bottom curve of the guitar body. I centered and marked it the same as I did with the main component of the preamp. I cut and filed the hole in the same manner as well. All the components fit together nicely. At this point in the build, we progressed to the point where we can begin wiring the components together. On the breadboard here, I wired up a Atmel chip. I'm not going to redo that. I'm going to take this package here, which is the Adafruit Metro Mini, which is a really nice little unit. With that, I can probably nest it on the bottom of the audio codec here, and I can take this TFT screen, I could nestle it right here, and then I have a little breakout board here. I could put some buttons on it so we could have some controls right there. Oh yeah, I'll also maybe need to put in a 3 or 5 volt regulator and possibly this amp here. So that's what I'm going to work on. Let's see what happens. While Ben is away, I'm utilizing his bench to fit together and wire the components. I removed all the headers and used adhesive to attach the microcontroller to the bottom of the audio codec with a small piece of plastic packaging in between. I wired the components directly to each other, trying to keep the unit small and compact. Well, I hot glued and taped and screwed the components together. Have the TFT screen on front with some buttons next to it. And then below that is the audio codec. And then on the bottom, I have the microcontroller. And I got everything wired. It's connected through SPI, and then the GPIO for the buttons is actually going to the GPIO breakout on the audio codec board. Miss Corbeil took some measurements of this. She set it on the guitar and saw how it would fit. And she's going to work on the enclosure. Meanwhile, I'm going to improve the code that's on it.
So it was my job to create the case for Felix's schmancy device here. So step one was taking a picture of the guitar with a ruler in the picture so that we could maintain the scale, and then taking that picture and putting it into Illustrator and tracing the curve. So once I had the curve, I could start making the side of the case. And so I had the matched curve, and then I had to figure out how big it needed to be and at what angle it needed to be to make sure that we could accommodate the actual circuit board. Once I had that, I had to figure out how wide it was going to be and start tracing out the faceplate. So first, I did the prototype to make sure that everything would fit in there, made little slots for, we decided we're going to use magnets to hold the case to the guitar so that we would damage the guitar as little as possible. Then I chose my material, and I decided I was going to use this approximately 1/4 inch thick plywood. So once we did that, we were able to kind of get it all together, and I think it turned out pretty good.
All right, so I'll show you the current state of the TFT screen here. As you can see, the text isn't very legible, and there's lines going all across the screen. Turns out that this thing is really delicate, and it can be broken quite easily. And let me tell you the story behind that. Karen and I were both working on this. She was focused on getting the enclosure together, and I was focused on the code. We were kind of rushing. We were passing it back and forth, and she handed it to me once, and it had the front plate on here, this bezel, and the screws were partially in there. She understood that it shouldn't be screwed in all the way, but I didn't. I tightened the screws down, and there wasn't any tolerance for the screen, so it cracked the screen. There weren't any spacers in there or anything. So the screen was broken, and I had to abandon the recording module. So at that point, I said, you know what, let's finish putting the guitar together, and got the strings on, and it's a really nice acoustic electric guitar. So we made it, and it's pretty cool. I still would like to share with you the code that I come up with to control this thing. So we're gonna have that as bonus content, and there'll be a link imposed on the bottom of the screen or somewhere on the screen. Just click on it, you can see the bonus content. It'll be me droning on about this code here. It's really riveting and it's gonna be great, so check it out. I know you love it.
All right, Felix, your acoustic guitar is now an electric guitar. You want to show us what it can do?
Yeah, it's pretty cool now. Sounds nice, huh?
Yeah.
Got it all tuned up, got the strings back on.
Okay, so you already own an acoustic electric guitar, right? So what was the price difference between buying an acoustic electric guitar and taking an acoustic guitar and making it electric?
I paid about $300 for my acoustic guitar that was already had a preamp in it. And this is entry-level guitar. I paid about $100, and it was like, I was quite surprised for the quality. And it was like $10, $9 to $10, including shipping for the preamp. It was pretty easy to put it in. Maybe it took me like an hour and a half or an hour or so.
Given all of the time and money in the world, what would you do in the future?
In the future! I think I would go down the path of becoming a luthier.
Ooh.
I think that would be a lot of fun. I imagine taking a sheet of electroluminescent sheet and carving it out to the shape of the guitar and putting it on there and having a mask on it so I could have some cool lighting symbols on it. And then maybe inside I would put some lights and make them sparkle, and possibly completely rebuild and design my own preamp and configure it in a way so that it could translate the notes into MIDI signals and output them to some sort of a MIDI controller or something.
That sounds really cool.
Yeah, that'd be a lot of fun. Hey, that's all the time we got for today, and that project sure was fun.
It was. So if you have made any musical instrument modifications, let us know in the Element 14 community on element14.com/TBHS. And don't forget to look for us on Twitter, Google+, Facebook, and YouTube. You can find me as The Heck with Karen. Oh, and next week, Ben's back.
Oh man, I sure miss that guy.
Yeah. In the meantime, dance party.
Right on. All right, check out this sweet riff. 2, 1. All right, so I'll show you the. So your kitten just died. Because your grandmother had a heart attack and she fell on the kitten. All right, check out this sweet riff.
Whoa, Felix. That's a bit much.
The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.